Okay, I think we shall begin. A very good day to you all, wherever you're dialing in from. Thank you for taking the time to join us for today's Global Floating Offshore Wind online conference organized by Scottish Development International. My name is Kevin Liu. I am the Head of Energy for Asia Pacific, based at the British office in Taipei for Scottish Development International. And I will be your host and moderator for the next 2 hours or so. Now, before I hand over to our first speaker, given the very large audience we have today, well over 1,000 people registering, and I believe now 500 people already in the audience, it is imperative of us to, first of all, mute you automatically and also ask you to turn off your cameras. Please do use the Q&A box to ask questions, and please note that you are being recorded and the full recording with the slides will be emailed to you after the event. And finally, we do have simultaneous interpreting available in 3 languages today: French, Mandarin, and Japanese. So if you haven't done so already and need interpreting, please use the interpretation icon at the bottom of your screen. It's the little globe, and you can choose your desired interpreting channel. And with that, I would like to hand over to David Rennie to give us some welcome remarks. Over to you, David.
Thanks, Kevin. Good morning, or indeed good afternoon to everybody joining us. Really pleased that you've taken the time, and I hope you find today a very useful event. So my name is David Rennie. I head up the Energy Global Trade team at Scottish Development International. For those of you who don't know, Scottish Development International is a trade and investment agency for the Scottish Government. I'm based in Scotland, and I head up the Global Energy Trade team. So our job, and that of my team, including Kevin and colleagues, is to help Scottish companies in the energy space export trade, in essence, sell what Scotland has to the world. And of course, we have a very strong track record in energy, predominantly in oil and gas, but as we know and as we'll hear today, we now have a further offering to the world in the world of offshore wind. So we have, Kevin, I think is going to put a slide up here at this point. We have, I have a team of over 30 odd people, some of them based in Scotland, but we have a lot of people based around the world. We have a relatively new start based in Linda Miles, based in Australia. We have Kevin himself, who's based in Taiwan. We have people based in Western Europe, in the Netherlands and France. We have colleagues based in Kuala Lumpur, India, and a post focused on offshore wind in Boston. So for us, offshore wind is a key market globally, and there are many parts of the world where we think we can add value and work with partners. So again, many of you will know this, but perhaps not all. Scotland is home to the world's first floating offshore wind farm, developed by Equinor, Hywind Scotland, and currently the world's largest offshore wind farm, the Kincardine project. So we have a lot of experience, a lot of sort of breakthroughs that we're ready to share with the world. And that, is a whole range of that covers a whole range of aspects, in terms of strategic development, consenting, supply chain, inspection, environmental management, big crossover between our oil and gas experience as we move into offshore wind. So you're going to hear a lot about that over the rest of the seminar. So I think perhaps just before I finish up and hand back to Kevin, offshore wind, like many businesses or many sectors, is hugely collaborative. It's a fairly complex and new and emerging sector, but we're going to need a lot of cooperation between companies and between countries across borders. We feel that there are many Scottish companies, some of whom you'll hear from today, who have that know-how, have that expertise, who can help share that experience, support projects on a global basis, and help many countries and indeed companies solve their engineering challenges. So with that, I'll hand back to Kevin. I'll wrap up this seminar at the end. Thanks everybody for joining. I hope you find this a productive session. So Kevin, back to you.
Brilliant. Thank you so much, David. Now, moving on to the main part of the program, we have split the event into 3 sections. And the first section will look at the policy and the industrial strategy around floating offshore wind. And we will kick off with a presentation from my esteemed colleague, Paul O'Brien, from the Deep Wind Cluster to talk about cost reduction, which is something indeed that as SDI we have engaged with partners from across the world on. So over to you, Paul O'Brien.
Thank you very much, Kevin. Good day, everyone, wherever you are in the world. We're going to be talking about cost reduction, and my presentation is split into 2 sections, a now and look at the future tomorrow. We need to look at what we are attempting to do now and then move on to what we need to do next. So next slide, please. As David has already referred to, we have 2 of the world leading projects already. One of them has been up and running for a while. Hywind Scotland from Equinor has achieved some of the best capacity factors in the world, recently hit 57% capacity factor. So tremendous example of why floating wind is going to be a huge addition to offshore wind, because it can reach the wind resources that fixed wind cannot reach. Kincardine project is still under construction. It's just about to be finished, and it will become the largest floating wind farm in the world. So as David referred to, we have some experience in this area and some world-beating projects already underway. Next slide, please. Now we need government support to make this happen. The emerging floating offshore wind is still an emerging industry. So we are reliant on UK government in this regard to support the industry. The contract for different mechanism is our support mechanism in the UK, and it is being changed this year. It will be announced later this year exactly what these will actually be. But one of the areas that we're looking at is what's called an administrative strike price. So it will be the first time that that will be set for floating offshore wind. And we're hoping that it's going to be enough to engender the first 1 gigawatt of floating wind in the UK by 2030. Now, that is not the industry's target, that is the government target. The industry are looking, and in fact are already calling for a double that, a 2 gigawatt target to be added to this. But because we're changing the contract for difference mechanism, floating offshore wind does not have to compete with fixed wind in this series. It's a competition, so it's a bidding competition. So floating offshore wind will now just compete with each other. So that is a great step forward for floating offshore wind in the UK. Next slide, please. What's coming next is our pre-commercial projects. So we already have 2 announced. Pentland Offshore Wind, which is a 100 megawatt project in the far north of Scotland, likely to be 7 to 8 substructures with perhaps 14 megawatt turbines on them by the time it kicks off in 2025. And the Salamander Offshore Wind project from 2 of our Deep Wind Cluster members, Simply Blue and Subsea 7. I should have said that Copenhagen Infrastructure Partners, that are delivering Pentland, are also members of the Deep Wind Cluster. Deep Wind is the largest offshore wind cluster in Europe, and it is the lead floating wind cluster in the UK, but possibly Europe as well. We have 214 members in our floating offshore wind subgroup. So Salamander, 200 megawatts, and it's expected to kickstart in 2026. And we're looking at these as the so-called stepping stone projects to achieve cost reduction by increasing the number of substructures. So we're going to learn by doing in this regard, and that is going to really give us tremendous steps towards cost reduction in looking at how to serialize the production of the substructures. Next slide, please. Now, the research that's happening at the moment, we have a number of programs running. You will hear a bit more from Ralph later, who is involved in the Floating Offshore Wind Centre of Excellence. One of the reports that they produced recently was a cost reduction pathway to subsidy-free, and it's looking at really the deployment that we need to achieve to get the cost reduction that's required for parity with fixed wind. We've just closed the BAYS Floating Offshore Wind Demonstration Programme, 17 million fund, and it's looking at three main areas: mooring and anchoring, dynamic cables, and the floaters and foundations themselves. The Floating Wind Technology Acceleration Competition from the Carbon Trust, which was funded by the Scottish Government, again had 4 challenge areas, and we're going to be looking a bit more closely at what has come out of those challenge areas. So that project has been running a while, so we now have results from it. Next slide, please. So this is from a report, Macro Benefits of Offshore Wind in the UK, which was produced by the Ore Catapult for Crown Estate Scotland. And it looked at a number of areas where cost reduction could be achieved. And we're looking at these particular areas 1, 2, and 3. Kevin, if you just click through that, I think it's again and again. There we go. So those 3 areas alone are responsible for 52% of the cost reduction, and 2 and 3 in particular, installation and the substructures, are probably, when it comes to economies of scale and capex, the areas that we need to concentrate on. Cost of capital, if we can take care of some of the others, cost of capital, which is linked to risk, will come down as we reduce the cost of offshore wind. And those 2 areas, 2 and 3, are the ones that we need to concentrate on. So that report looked at reducing levelized cost of energy from 200 megawatts per hour down to 85 by 2027. That is extremely ambitious. Only time will tell if we can achieve that, but it was forecasting that we need to deploy 6 gigawatts by 2031 to achieve parity with fixed. Next slide, please. So we've decided the areas that we need to concentrate on. So going back to the Floating Wind Technology Acceleration Competition, I'm not going to go through all of these because we don't have time, but the first 2 challenges looking at exchanging large turbine components offshore for floating wind, which is very difficult to have a floating crane and a floating system trying to remove items from a moving nacelle at the top of the tower. So that's one area that needs to be looked at. There's also, the jury is out whether the industry will disconnect and take them back to shore for those repairs, or will we come up with an innovative solution that overcomes the challenges? Using a jack-up in the water depths that we're talking about is probably not an option. So we need to come up with a solution. And those first 2 actually look at what those solutions could be if we stick with offshore, or if we're intending to disconnect the substructures and bring them back to shore. So the first one is a crane that utilizes the nacelle itself and the structure of the turbine to support taking out components and lowering them down to the substructure itself. The second one from Aker Solutions, the splice box, it's to do with disconnecting the substructure completely, and it joins the 2 array cables that would attach the turbine to the rest of the line, and it allows those 2 cables to be reconnected so that not all of the series is off at the same time, and allows you to take the substructure back to shore. So these are the kind of areas that we need to decide what we're going to do when we come to looking at the operation and maintenance required for large activities such as removing blades, taking out the gearbox, etc. So as I say, the industry has not decided which way to go, so we're looking at solutions that will deliver both. Next slide, please. Other areas of the challenge, particularly challenge 4, which is very much looking at the installation and looking at the mooring lines and the anchors. So we have at least 4 companies involved in those projects. The ones that are highlighted are all members of the Deep Wind cluster. Dublin Offshore, Recam Technologies and Vryhof are involved in these projects, looking at different technologies that will reduce the cost of the mooring system and the anchoring system. So it's either commercial manufacture of the 3D printed suction anchors, looking at lowering the cost of the suction anchors, or like Vryhof's commercialization of a cost-effective mooring line tensioner, and that's going to move that from a technology readiness level 5 up to 8. So it is ready for commercialization after this project. And these will all contribute to cost reduction for the industry. Next slide, please. So we're now looking at tomorrow. This is where we are in Scotland at the moment. We have about 10.2 gigawatts of projects that are already announced and will be moving forward. That's the list there. That's where we are with them. Operational, under construction, consented and planned. And the next round will be ScotWind itself. So this is where we are just now. We're looking to the future projects, and there will be 15 sites, about half of which is expected to be floating. These will be the first commercial projects announced in Europe at commercial scale, which we believe is 500 megawatts and above. Those circled are in deep water. So these are 100-meter plus sites. So they will definitely be floating. Some of the others are mixed sites. It could be fixed or floating, but we're expecting that of the 10 gigawatts that's expected to come out of this project, about half of it could be floating wind. So we could see up to 5 gigawatts of floating wind in this leasing round. Next slide, please. We're also looking at the energy transition market. So the oil and gas industry in Scotland, in particular, we have about 90% of this market in the UK. They are looking at electrification as a way of decarbonising the production of oil and gas. And offshore wind is going to play a very, very strong role in that. And this will be another opportunity for projects to learn and to get cost reduction through further demonstration of technologies that will achieve that. Next slide, please. And most importantly, we need to look at the industrialization of manufacturing the substructures and the assembly of them. So we need highly automated substructure final assembly facilities at portside for both steel and concrete systems. Many people are looking at concrete as a cost reduction opportunity. But the real key will be the design of the substructures. We need to design the substructures for manufacture. So whether that's steel tubular components from tower manufacturers or slip forming of the concrete modular components, we believe this is the way forward for cost reduction on the substructures. We need to be very near to the sites, the floating wind sites. That has been proved, particularly at Kincardine. We cannot be trying to move these very large substructures, which are 80 to 100 meters in diameter. They cannot be coming from any further away than about somewhere in the 100 to 200 kilometer range from the actual floating wind site. Next slide, please. And finally, we are looking at the learning. We need the learning to get the cost reduction. The report I referred to earlier looked at a 13% cost reduction through the learning itself. So we need these stepping stone projects. We need to see that there is an opportunity for mass production of the substructures to get the investment that the industry requires. And why will this be done actually very close to where the sites are? The picture is of one substructure being loaded onto a semi-sub vessel to be transferred from Navantia in Spain to the Kincardine project in Scotland. That proved to be a very expensive exercise. And Cobra themselves are saying that they can't do that again if they're going to look at a commercial scale project. We need to resolve how to deliver these substructures much closer. And so the pre-commercial and the energy transition projects in Scotland will be very important to achieving how we're going to actually deliver these substructures in a very cost down manufacturing opportunity way. And I think that's the last slide. Just check, move on to the next one. Yes. So hopefully that's of interest. I ran through that pretty quick because we don't have a lot of time, but hopefully you can see that we know where we need to achieve the cost reduction, and we are moving in the direction that we believe will give us that cost reduction, which will see floating wind become a major competitor to fixed, or rather not a competitor, because a lot of countries only have deep water. So fixed is not an option. They just need floating offshore wind to become cost competitive with other forms of energy. Thank you very much.
Thank you so much, Paul. We did try to allow some time at the end for questions and answers, and we have received a couple of questions, but in the interest of keeping us on schedule, I'm going to move on to the next speaker. Now, Kincardine has been mentioned a few times already, so it is my great pleasure to introduce Lord Nicol Stephen, Chief Executive of Flotation Energy and one of the people behind the Kincardine project. Over to you, Nicol.
Thanks very much indeed, Kevin. And it's a great pleasure, a great honor to be able to speak to so many people in different parts of the world this morning. Can I start by paying compliment to Scottish Development International and also to the work that Paul O'Brien and his team are doing. I used to be involved in politics. I was the Scottish Energy Minister at one time, and I also had responsibility for SDI, for Scottish Development International, and the work that they're doing in relation to renewable energy is fantastic. And it's built on the fact that Scotland is leading the way in relation to both offshore fixed and very much in relation to offshore floating wind. I'll briefly introduce my company that I'm the chief executive of. It's called Flotation Energy. And that gives you the clue as to our area of specialism. We are an offshore wind developer headquartered in Scotland. We are pioneering work in relation to the energy transition. We're working closely with a number of oil and gas companies to bring renewable electricity to their offshore platforms. And we also conceived and designed and developed the Kincardine project, and we've been working with our partners, Cobra, the Spanish company, in relation to not only the Kincardine project, but also a number of other projects in the United Kingdom and Ireland. We've got an international pipeline now of around 10 gigawatts of projects, and we have offices as well as in the UK. We also have offices in Japan, Taiwan, and Australia. We were successful in the fixed bottom round, which recently concluded back in February, which was operated by the Crown Estate in England and Wales. And you can see our site there, which for those of you who recognize the map, you can see is in the Irish Sea, near to Blackpool and Liverpool. We were very pleased to win this round, which was a fixed bottom round. You can see the other winners were BP, RWE and Total. And we were obviously up against some very stiff international competition, such as Ørsted and Shell and Equinor and CIP and Iberdrola and others. So to be successful in one of those sites was really a game changer for us, a huge step forward. I'll move on to the next slide, I think. I've mentioned the energy transition and that we're working in this area. You'll see the concept there in the plan. We build a floating offshore wind farm, and we have one cable that goes to shore and one cable that goes to the offshore oil and gas platform or platforms. The wind farm, depending on its size and scale, could serve either one major platform or a number of platforms, perhaps in the central North Sea or the northern North Sea. A large area of the North Sea could be served from one platform. We've got a project that we're working on with a major oil and gas company right now that we're hoping to get operational in the mid-2020s. And it would be a 300 megawatt project. We're also working both internationally and in England and Wales in other projects where we're going to be partnering with oil and gas majors. The advantage is that it decarbonizes the offshore operations. All of the offshore electricity is generated from gas or diesel on our offshore platforms in the United Kingdom, and it's become a priority of the government to decarbonize those operations using renewable electricity. And the importance of the connection to shore is that if ever there is intermittency, if there's not enough wind blowing, as well as being able to export electricity to the shore, we can also import electricity from the grid to the offshore oil and gas platform. Next slide, I think. All of this gives us a great platform, a great launch pad to do things in other parts of the world. And having developed Kincardine, having seen it becoming a success and becoming the largest project in the world, we decided to move on from there. We could have stopped and rested and focused only on Scotland or the UK, but we are determined to do more and to support the expansion of the industry, especially the floating wind industry in Asia, in other parts of Europe, and in Australia. And you'll see there that we have got projects and offices now in both Taiwan, in Taipei, and in Japan, in Niigata. And we are actively seeking partnerships with local developers, with local companies that are interested in the development of both fixed and floating, but clearly our expertise is in floating. We've got projects as well. I don't know if anybody today is listening or looking in from Australia, but we've now also got projects and offices in Melbourne and Perth, including energy transition projects where we're working with one very significant oil major. Next slide, I think. Just briefly, we'll rattle through Kincardine. As I say, I and my colleague Alan McCaskill, we conceived the project back in about 2013. So it's taken us 7 or 8 years to get it to the stage we are now at, which is that it's all 5 major turbines are on site. You can see the details of it there. I won't go through it all, but we've got some of the largest turbines in the world floated. And you can see that the turbine being floated to site there by the vessels. So a very significant structure, 194 meters to tip height. And if any of you visit Aberdeen, please get in contact and we'd be delighted to welcome you and to show you the Kincardine site. We were a little bit delayed because of COVID, because of the completion of the substructures, but on balance, I think we've done pretty well to get the project to this stage as a demonstration project in the time that it has taken. And we're obviously very pleased that it's now the world's largest. On to the next slide. I just wanted to give you a sense of scale. Perhaps the last photograph did give you some of that sense, showing you the vessels alongside it, but I've circled here in red some people looking down at one of our substructures. it is very, very large, and you only get a true sense of scale when you're up close to them. And maybe the next slide gives you a sense of just that scale. You can see the substructure there on the back of a vessel. You can see them in the context of other industrial facilities. They are very big investments, and part of the cost reduction is definitely about getting these foundations made as cost effectively as we possibly can. And as Paul was saying in the previous presentation, we need to look at modularization, industrialization of the process, and being able to do it close to site. These are major lessons for the future, and we are determined to be an important part of that. To do that, to achieve that, we will need to look at improving some of the facilities in Scotland, but I know that both companies and government are committed to that, because this industry is so important to the future of our country, and I believe very important to the decarbonisation, to the net zero targets for all of the rest of the world. Next slide. So in summary, just a bit more about flotation energy. We believe we have a unique team and some real expertise and a very strong track record. We've got this pipeline of projects internationally. We've been awarded the Crown Estate lease with our partners Cobra in England and Wales. We're pioneering the energy transition, developing projects in Taiwan, Japan, Europe and Australia. We strongly believe that development has the potential to be a domestic business. There are some very major multinational players in this business, and they're highly respected. But I would like to see more local companies getting involved in development, and Asia is expected to be the major growth market for offshore wind in the period through to 2050, with over 600 gigawatts of new projects to be developed. And that's why very much we welcome opportunities for collaboration and for partnerships. Just a sense of scale. The next generation, where is all this leading? I mentioned the tip height of the existing turbines at Kincardine, 194 meters. The Eiffel Tower in Paris is 300 meters. And it's expected that in the next 10 years, that's where these wind turbines could go, a similar sort of height. So if we skip on to the next slide, you can see it there. Sorry, one back. You can see there the sort of scale of turbine that you would expect to see within 5 or 10 years as we move up to a 20 megawatt turbine. And we can float these. I mean, that's the message. We can float these. We already have the skills, the technology, the knowledge, the know-how to be able to do that. So how do we achieve that? And that's what I'll just turn to at the end of my presentation. Well, first thing is clear. We need to get ready for bigger and bigger turbines and projects. So I see in some countries that I've visited just before the lockdown that they're still very much about early stage testing, experimental projects, maybe 1 or at most 2 or 3 turbines. We're beyond that stage now. We can go to the full-scale commercial stage. Second point is, as Paul was mentioning earlier, different foundation types are probable. I was going to say likely, but I think probable is the right word to use here. That means they could be semi-sub, they'll probably be the most significant, but they could be spar or tension leg, they could be steel, they could be concrete. It's unlikely that we will standardize on one single solution as we have with the turbines. You know, the turbines are 1 steel structure, 3 blades, pretty much the industry standard. I think with the foundations, there's definitely room for different designs. And there are at least 8 or 10 credible designs out there in the market at the moment, which is good for competition and also good for cost reduction. My third message is find the very best wind and scale up. You know, with high wind and with Kincardine, we're seeing capacity factors for floating wind that are pushing up over 50, over 55%. And costs are starting to fall very significantly. So there's a real opportunity to push forward and get these floating sites in the strongest wind speed areas where there's less visual impact and less environmental impact. Floating sites are better for seabirds and better for sea mammals, the dolphins and the whales. And my final point is that governments, it should really say, governments need to go for it right around the world. If they're serious about net zero by 2050, they need to support floating in this transition period to get to the full-scale projects that will make it one of the cheapest and one of the most cost-effective ways to deliver renewable electricity worldwide. And then just a few quotes on my final slide. Is there a floating wind future? There are some cynics. I'm here in Aberdeen, Scotland, the heart of the oil and gas business, not only in Scotland, but arguably for Europe. And many of my friends were quite cynical when I went into this industry more than 10 years ago. Some of them even smiled or perhaps even laughed. They thought there was a very, very long future for oil and gas and a very small future for renewable energy. Well, all I can say is they're not laughing anymore. They can see the future happening. And remember that Tom Watson, when he was chief executive of IBM, said that he thought there was a world market for maybe 5 big supercomputers. Remember that in 1993, Bill Gates said, the internet, we're not interested in it. And remember what Gary Hamel said in his book, Competing for the Future. It's not about predicting the future. It's not about monitoring the future. It's about getting out there, making the future happen, shaping the future, making the future a reality. And that's what I believe together we can achieve. A very exciting future for offshore wind, both fixed and particularly for floating. Thanks very much.
Thank you so much, Nicol. I'm going to risk eating into our program ever so slightly and spend a couple of minutes trying to bundle the flurry of questions that we've received in the Q&A box. There's been quite a few questions, Nicol, around the type of technology you've chosen by way of the turbine and the foundation. Do you have a preference? So that's question number 1. And question number 2 is, what is the sort of scale that you're now looking at in reference to the commercialization of future floating wind farms?
I'll try to give quick answers. Our initial projects, we've used a design by the French-American company, which is now owned by a number of oil and gas and renewable energy majors, which is called Principal Power. It's a steel design, it's a semi-submersible structure. It was the most mature technology at the time by some significant way. It's been in the water as a test and demonstration project since about 2010-11 off Portugal, and it was ready to be scaled up. But others are coming through, and there are a number of them. I won't mention them all, but some of them are extremely credible and are achieving a significant technology readiness level. And as I said, I think competition in this sector is likely and is a good thing. In terms of scale, we've got another project, which is a 100 megawatt test and demonstration project that we hope to announce in the next couple of weeks. Then we've got the energy transition project that I mentioned in my presentation that is 300 megawatts. And then in the ScotWind process, I think everyone is expecting it to scale up to major floating projects of perhaps 1,000 to 1,500 megawatts. And it's only when we achieve that scale that we'll get the full impact of cost reduction. So these are very big projects, I know, compared to, for example, Taiwan, where you are, Kevin, where the project size is being kept by government at around 500 megawatts. And you can still have a very credible project at that scale. 500 is a good project size. So if governments go in that direction, it's absolutely fine, but there's a big pressure, especially from the multinational developers in this industry, to go for ever bigger projects. And 1,000 to 1,500, I think, will very quickly become a norm in the UK and in Europe.
Well, thank you so much for those very clear answers. For all the questions that have been asked in the Q&A box that we can't get to, we will make sure that we send these to all of the speakers after the event and that they are responded accordingly by email in return. Well, thank you once again, Nicol. I know you might have to dash off, so thank you very much for your time. And we will now move on to the supply chain innovation part of the program, part 2, and starting with Ralph Tor, who is the program lead at the Offshore Renewable Energy Catapult, specifically looking after floating offshore wind. Over to you, Ralph.
Good day, everybody, and thank you very much for joining us. So I'm just going to take 5 or 10 minutes to talk through some of the work that we're doing in a program called the Floating Offshore Wind Centre of Excellence that we manage. What I'm going to try and do today is just outline some of the opportunities that have already been covered well by Nicol and Paul, but then talk a little bit more about the approach that markets are looking to take to ensure that floating offshore wind kind of scales rapidly, but also in a way that creates value and employment in those markets. So yeah, Kevin, if you could just flick over. So as Scotland, has known for a long period of time, there is really a big opportunity for floating offshore wind in the seas around Scotland, not just to help Scotland reach its ambitious net zero targets, but also to help support the transition of skill and experience from the oil and gas industry into the renewable energy industry, and just more generally to drive economic growth and raise the level of industrial activity. And particularly if you look at where floating offshore wind can be deployed across the UK, it is able to bring offshore renewable energy to regions where it hasn't existed before. And there is a really important element that the industry can bring in the UK of driving, regional economic growth. So as well as governments being very focused on, cost-effective ways of delivering net zero, I think in all markets we need to be mindful that floating offshore wind, like any major new industry, also has to make a contribution, to broader economic growth. And the program that we're running, and I'm going to talk briefly about today, is all about supporting industry, government, and other stakeholders to go through a process where we are growing an industry really very rapidly, but making sure that that's done in a way that is sustainable, brings benefit to the project developers, but also the broader supply chain. So in terms of the acknowledgement that's been made of floating offshore wind and the contribution it can play, we've already touched on the key benefits for the markets that are developing floating offshore wind. So we know that it can deliver cost-effective energy. We know that it can play a major role in delivering net zero, but also it is going to be a driver of economic growth. So the organisation that I work for, the Offshore Renewable Energy Catapult, worked with a number of project developers to establish something called the Floating Offshore Wind Centre of Excellence. So this is an industry-led collaborative program that works with industry project developers, but also a range of other stakeholders. And the real focus of the program is to accelerate the commercialisation of floating offshore wind, but also to make sure that that is done in a way that creates opportunity for the supply chain, which in turn allows them to invest and deliver projects more cost effectively. Nicol and Paul have talked about the importance of local supply chain, domestic supply chain, being key to delivering projects cost effectively. So there is this requirement for government, industry, and the supply chain to work together so that when these projects are primed to be delivered, the supply chain is there to deliver it cost effectively, which works well for the supply chain, works well for the project developers, works well for government and other stakeholders. So this industry-led collaborative program, we work across a range of different subject matter areas. So we obviously look at some of the technical challenges that the industry is facing, look at supply chain specifically, operations, so the approach to kind of project development and delivery, We also look at the development and consenting process, and also something called delivering net zero, which is really about the kind of underpinning policy that government and others are establishing. So we work across all 4 of these work streams. And the key thing to highlight is that commercializing floating offshore wind, scaling it, is not just a technical challenge. There are, of course, technical challenges to overcome, but actually, as we continue to develop the industry, a lot of the more acute challenges are going to start to shift across to things like supply chain capacity, the development and consenting approach. So we very intentionally established a program working across all 4 of those areas. The program's only 2 years old, but we've already committed to invest more than £3.5 million in enabling projects and activities. And really what we are looking to do is work with our partners to identify areas of common challenge, and to work collaboratively to address those challenges in advance of need. Obviously, you'll be aware that Scotland has launched the ScotWind process, so we're looking for the first large projects to go in Scotland towards the end of the 2020s. That's a great opportunity. It probably sounds quite far away at the moment. It's not that far away, but it does give us an opportunity to work collaboratively over the next 5 or 10 years to address some of these issues, so that by the time the first large-scale projects go in the water, you know, we've addressed many of the areas that might otherwise have led to increased costs or increased risk. So the program itself is led by a board of industry partners, and those industry partners are absolutely committed to supporting commercialization of floating offshore wind, obviously for their own benefit, but also they are absolutely aware that taking government and supporting the development of the supply chain is going to be critical to them delivering cost-effective projects, both here in the UK, but also internationally. And actually, a lot of these organisations are really starting to think more broadly about how they engage with the supply chain and support the development. There is, you know, there is a requirement for these organisations to you know, to almost develop that supply chain development skill set itself. And that is part of, you know, their competitive advantage when they're moving into new markets, the fact that they know and understand how to work with the supply chain, how to develop the supply chain, so that their projects are able to be delivered cost effectively and also at low risk. So yeah, supply chain development is a really critical part of our program. And so I'm just going to talk a little bit more over the next couple of minutes about the kind of broader challenges that we have to developing a supply chain in any market, but also talk a little bit about some of the work that we're doing on that. So if you could just move on to the next slide, please, Kevin. So yeah, so in terms of a kind of broad supply chain strategy, I've tried to develop a couple of thoughts about what I think you could apply to really any of the kind of leading floating offshore wind markets. So there's really 3 main areas that we're looking at the moment. So one is projects and pipeline, one is strategic supply chain capability and infrastructure, and one is innovation. So I'll talk through these briefly. So projects and pipeline, what's really important to support the development of supply chain and to underpin some of the big investments that need to be made in projects, in supply chain organizations and infrastructure, is guidance by government about where the industry is going. It's great in the UK that we have a target for 2030. Paul's already mentioned that, you know, that there's already, I think, a view that we could be more ambitious than that 2030. But ultimately, 1 or even 2 gigawatts by 2030 doesn't really provide guidance about the scale that floating offshore wind industry is going to reach in the UK. So what we're really looking to do at the moment is to work with stakeholders to establish credible but ambitious targets for 2035 or 2040, because they're the kind of dates that will really give us a guide as to where floating offshore wind is going in the UK in terms of the scale of deployment. And then the second point is making sure that we're taking an approach which balances and coordinates the leasing process, the consenting process, and revenue support. It's really important that these processes are run in a coordinated way. Doing that reduces the time to get projects in the water. It also reduces costs by preventing, for example, pinch points in the supply chain where you have periods of boom or bust, and various other you know, benefits as well. But they are separate processes: the leasing process, the consenting process, and the issue of revenue support. But it's really important that we manage these very carefully, particularly while the industry is growing rapidly, to make sure that that works successfully. And then the second point that I'll talk about is strategic supply chain and infrastructure development. Nicole's already given us a great insight into just the scale of the projects and the scale of the technology. And I think for most markets, but particularly here in the UK, there is a recognition that we need to develop world-leading infrastructure and attract supply chain capability here to actually deliver the scale of these projects. And the nature of infrastructure development and bringing kind of strategic supply chain organizations to the UK, these are not things that can be mobilized quickly. They are not the sort of thing that can be mobilized post FID. We are working today to make sure that over the coming years, we are developing appropriate infrastructure and attracting and developing the right supply chain capability. Because even with all the great skills and experience in the lower tiers of the supply chain, unless that activity is being delivered from the UK, for example, or from within the market, it acts as a real barrier for the lower parts of the supply chain. There are clearly uncertainties about the technologies that will be used, the scale of the projects, but we certainly feel at the moment, and we're working with stakeholders on this, to take some smart strategic investment decisions over the coming years, which account for that uncertainty, but also ultimately don't mean that that uncertainty is a reason not to make any investment or not to move forward at all in this area. And yeah, finally, the point to highlight in infrastructure is that it is just critical that there is no credible way of delivering these projects at a large scale unless we have this infrastructure within the market. And if we don't develop it within the market, we're going to force developers to deliver these from outside, which will definitely result in higher costs, likely also increased risks, and ultimately will be a missed opportunity for the market itself. And then the third point is the work that we're doing looking at the importance of innovation. Obviously, innovation is really important because it's going to play a key role in cost reduction. But if we go back to my opening slide, innovation is one of the key drivers of markets, creating value from an industry, not just by supplying products and services into projects in their own waters, but also by exports. And so the innovation program that's being developed in the UK around floating offshore wind isn't just focused on cost reduction. It's also looking at what products and services is the UK already, have world-leading experience and expertise in, and hence we can take those and hopefully support other markets to grow and develop cost effectively by taking products and services across there. So yeah, the main focus, I think, for markets, and particularly here in the UK, is clearly substructure manufacturing and project delivery, but also in the UK and in Scotland particularly, we're looking at where the existing supply chain strength sits, and we're going to hear from a number of leading organisations shortly about that. So our particular focus at this stage is on dynamic cabling systems, mooring and anchoring systems, which are really critical components in the project, and areas where the UK and Scottish organisations already have kind of world-leading knowledge and understanding. So they're the kind of three main elements to a kind of broader supply chain strategy that any market would take. And I'll just touch on a couple of specific activities that we're doing in the UK in the Centre of Excellence to support the growth of the industry. So there's kind of three main themes to our strategic approach to developing the supply chain in the UK. So the first is working with our partners to make sure that the UK establishes itself and grows to become the leading floating offshore wind market in the world. We're already in a great situation, but there are a lot of other markets moving very quickly. So we want to make absolutely sure that the UK retains that leading position. But there is quite a lot of work ongoing at the moment to make sure that we're very clear about the role that floating offshore wind will play in net zero in terms of the scale of deployment. So that's a key part of our activity. Second area of activity for us is creating opportunities for the UK supply chain. So making sure that the projects that develop over the next 5 or 10 years develop in a way that mean the UK supply chain's got a really good opportunity to supply products and services into them. And then the final part of our activity is looking at how we can attract world-leading innovation and deliver it from within the UK. So working with our partners to make sure that the UK helps play a key role in addressing some of these really critical issues around, for example, dynamic cabling systems and mooring and anchoring systems. So yeah, thanks for your time today. I will hand back to Kevin now, and I think we'll hear shortly from a number of organisations involved in the industry directly.
Brilliant. Thank you so much, Ralph, for setting the scene. And I think what you're doing is a great reference for many of the other countries looking at setting up a floating offshore wind supply chain base, and indeed for offshore wind as a whole. We've mentioned substructures already. So on that note, let me hand over to Mike Wilson, who is founder and chair of Ecos IP, to talk about substructures. Over to you, Mike.
Good morning, Kevin. Good morning, everyone. Thank you for inviting me to present at your function today. I'm going to talk about the substructures installation method, substructures and installation method for our float system. This is a semi-technical presentation which shows in this first slide how a tension leg platform is developed for supporting floating wind substructure and how it's attached to the seabed. It's very often forgotten about because it's out of sight and out of mind. But one of the key drivers for floating wind is how do you make the floating wind substructure stay in the right position, and how is it nailed to the seabed. And it can be a very, very expensive process. For a 10 megawatt turbine to have a tension leg platform, as we've shown here, you need about an on-bottom weight, equivalent weight of about 5,000 tons. So installing 5,000 tons subsea is a very difficult and expensive task, so we need to find a different way to achieve this. Our float system is one such system that enables this to happen. By having a tension leg system, you have a suitability for all water depths and a huge range of seabed types. And we can use this to moor floating wind alongside existing oil and gas platforms or as part of an offshore wind farm. Next slide, please. The components of our system are an ambient lifter, which is our own proprietary technology, a micropiled template, which is owned by others, the floating transition piece, and the tension leg foundation. What is ambient lifter? It's a buoyancy-based subsea lifting system that can lift anything, not just floating wind structures. And it's a simple, scalable, robust technology that makes large structures towable and installable on site using our system. Some of the benefits of ambient lifter versus conventional technology is that it's simple components and simple technology, enabling low-cost local deployment, local being a key part of this. And it's a robust solution that can be installed large structures at any depth. And we can use this to install any size and type of foundation. And this enables, the technology enables much wider weather windows than if you use surface-borne technology to install. By comparison, heavy lift vessels are expensive, location dependent, and there's scarce availability. Very weather dependent, and their mob and demob costs are very high. So what are micropiles? Well, micropiles were developed in the 1950s and 1960s in order to stabilize onshore structures and are currently used for onshore wind turbines. And they mimic a seabed, they mimic a tree structure where the root nature of the tree enables the tree to stand the force of the wind during normal weather conditions. And it involves using a drill rig to grout in pins which form a lattice work like a tree root structure. And we are helping others pioneer this for the subsea market. So the benefits is that it's suitable for rock seabed and other seabed types, rocks, sand, clays. It's significantly cheaper than other foundation types, and again can be installed without surface-borne vessels being directly tethered. Next slide, please. So, floating transition piece, we all know the benefits of being able to float these to the site. In combination with tension legs, minimizes the movement and enables a low-cost power export cable to be used. Power export cables are a critical single-point failure for floating transition pieces or floating wind turbines. And basically this can provide a firm base for any standardish type wind turbine. So the floating transition piece, typically we would install with the tension legs attached to it and then ballast into site. The alternative to floating wind, typically the turbine is subject to lots of pitch and yaw, and the dynamic riser that you need with a conventional floating wind, again, you need a dynamic riser. Copper wire doesn't like being bent multiple times, and it's subsequently less effective in challenging weather conditions, which is why we have them in offshore wind locations. Next slide. So the tension leg foundation is tried and tested for many decades in the oil and gas sector. It uses vertical anchor wires or pennants, and it has a very small footprint. Now, this small footprint is actually critical for other seabed users. Instead of having a massive array over a couple of kilometers on anchor wires, which prohibits fishing and other activities, the vertical array means that you take due consideration for other stakeholders in the area. So the main benefits of the tension leg is that it remains vertical and you have smaller movements in bad weather, and it enables a lower cost export riser. The existing ones means large footprint, dynamic riser, and much more pitch and yaw and roll that needs to be taken care of by the turbine manufacturers. A little storyboard here, if we go to the next slide, please. So the micropile template can be towed to site with a small vessel and positioned accurately on the seabed using the ambient lifter system. Next slide. And the next slide. Now we have the templates on the seabed. We use a subsea drilling unit to install the micropiles through the templates into the seabed. Next slide, please. You can see here the ambient lifter being used to control the drill unit, which is then subsequently put on the seabed. During all this activity, there's only soft tethers to the surface, so there is no insignificant weather penalty. Next slide, please. So then we inject the grouts into the micropile system and make the piles into the very strong structures that they are. Next slide, please. Then the floating transition piece is towed to site as conventionally demonstrated with other technologies. Next slide, please. And then the floating transition piece is ballasted down and the tendons or the wires are maneuvered into place, again using ambient technology to help lift and maneuver these. Next slide, please. And then the ballast is removed and the floating transition piece rises and creates the required tension in the wires. Next slide, please. And then the power takeoff cable is installed. We have a proprietary technology for making sure that the movement that remains in the tension leg system is taken care of inside the nacelle. Next slide, please. And then we can connect these to others. That's my time up. Next slide, please. Again, ambient lifter can be used to install many different types of foundation. Graphically here, a ballast made of concrete. And concrete is a very interesting material because there are new green types of concrete coming to the market. More of that later. Next slide, please. We've done significant work on this with supply chain colleagues. Next slide, please. And we're currently working with the Nippon Foundation project, which looks at using the ambient lifter alongside some other colleagues' technologies for installing the turbines. Next slide, please. These are our partners. Next slide, please. So in summary, the float is towed from shore with no crane vessel needed. Typically, the micropile and ambient templates are 50% of the cost of the monopile. Range of water depths. We can use cheaper, more reliable power takeoff cables, reducing the dramatic lift footprint for wind farm foundations. That will do for me. Thank you very much.
Thank you so much, Mike, and I love the fact that you timed yourself and set an alarm clock. Thank you. Well, that leads us nicely onto the next presentation by Jason Guthrie, who's a naval architect with First Marine Solutions, and he'll be talking to us about mooring and anchoring systems. Over to you, Jason.
Thank you. Good morning, good afternoon, and good evening, everybody. My name is Jason Guthrie, and I'm a naval architect with First Marine Solutions. I'll be presenting FMS's capabilities today instead of my colleague Tom McCombs, who is away on other duties. I myself have a rather mixed engineering background, but my main focus has been in the maritime operations with specific interest in diving and subsea systems in general. Prior to my time in academia, I worked in Australia and New Zealand, where I got the chance to work with smaller scale mooring systems whilst working in the commercial diving sector. So enough about me, and let's talk about First Marine Solutions. Next slide, please. Thank you. First and foremost, FMS is a mooring system provider. It is what we've always done and remains a core aspect of our business. Within the world of mooring systems, you can pretty much name it, and I'm sure we've either owned it, installed it, retrieved it, or supported its development through our consultancy. Historically, we have been 100% oil and gas focused, but as we're a strongly forward-thinking company, we have started to make major investment into our renewables department, which was set up last year. Although we're a Scottish company through and through, with our headquarters in Aberdeen, our renewables office in Glasgow, and our expansive ports facility in Montrose. Although Montrose is very much our home port, we have established close partnerships with all major UK ports and many more worldwide. The company has enjoyed tremendous growth in the last few years, and with this, we are thinking about setting up offices outside the UK when the time comes. We're fully certified and DNV improved with ISO 9001 quality assurance accreditation that was just re-approved last week. And in addition to this, we have been recommended for ISO 14001 and 45001 by DNV themselves. Next slide, please. FMS is a core business within the larger First Tech Group. As with FMS, First Tech Group is oil and gas centered, but the independent businesses are turning their focus to renewables. A recent example of this is First Subsea, who are the chosen platform mooring connector supplier for the Kincardine project. Kincardine relies upon First Subsea's unique bull grab product to keep its floaters attached to its moorings and its station at all times. First Tech Group is owned by a singular investor, and this allows the group to rapidly respond to industry demands without having to satisfy the requests of shareholders before any major business commitments are made. Next slide, please. So what do we do? Well, as mentioned before, we are fundamentally a mooring service provider, but we do so much more than just rig moves, mooring design, ship chartering, etc. Next slide, please. In this slide, you can see some images indicating the 4 cornerstones of our mooring strategy: survey, installation, inspection, decommissioning. The key trait we pride ourselves upon is our responsibility to the client and to the environment. It is only through our holistic approach from cradle to grave that allows us to influence the entire moorings life cycle so that all operations are conducted in a safe and responsible manner. From initial site survey right through to midlife inspection and finally decommissioning, we are involved with it all. You'll probably notice that the last one is actually a photo of one of our last decommissioning jobs where we had to remove, replace and dispose of some 8 kilometers of 160 mil fiber rope. It was quite a big job. Next slide, please. FMS is a well-established service provider, and as such, we have had the opportunity to forge strong ties with most of the major oil and gas companies around the world. In addition to oil and gas, FMS is developing a strong portfolio of work with an ever-expanding list of renewables clients. You may notice that the selection of presented clients is a mix of big household names and much smaller niche operators. This is one aspect FMS is keen to highlight, and that is we're willing to work with anyone. No company is too big or too small for us. If you need a mooring solution, please come speak to us. Along with the above clients, the UK government has recognised FMS's unparalleled knowledge in the moorings field and has selected us to develop a white paper detailing the new British standard for mooring line design. As can be seen from our client list, FMS is a globally active company, and we appreciate that mooring solutions are required everywhere in the world and in vastly different conditions. Next slide, please. Although our position in Scotland has meant that our focus has mainly been on the North Sea, we invite and pursue work in all 4 corners of the globe. With more and more floating offshore wind developments in the pipeline, especially in the Asia Pacific, we are keen to establish relationships with developers early on so that we can all drive innovation together in these most exciting of times. As being an established service provider, we have developed strong relationships with many key suppliers who are based in Asia. Therefore, we already know who to speak to when a project is first proposed, regardless of where it is. Additionally, a considerable number of our staff have direct local knowledge of the Asia Pacific region by either having been born and raised there or from having lived and worked there for numerous years, such as myself. Next slide, please. From our oil and gas heritage, FMS has developed a wide portfolio of techniques, equipment, and suppliers. Here on the left, you can see one of our many rig moves being conducted. Thanks. And in the middle, you can see some of our top-class employees at our quayside facility in Montrose. As you can see, we're big fans of chain, and we know pretty much everything there is to know about it. On the right, this interesting looking device is actually the world's first full-scale contra-rotating tidal turbine. It was successfully installed and recovered for our client's Nauticity. This particular project proposed some unique challenges, such as holding station in highly energetic tidal flows with the use of dynamic positioning whilst performing 40-ton lifts on large construction vessels. Next slide, please. Being a fully integrated service provider, FMS's departments cover all key aspects of mooring installation. It is only through leveraging on each department's unique assets can we deliver a world-class service. FMS has several unique departments that are independent in terms of assets, but integrated in terms of workflow. This arrangement gives us the opportunity to ensure that all contracts are led by a singular staff member, whilst being able to quickly pull more resources online as required. Our survey office is fully kitted out with the state-of-the-art and cutting-edge equipment. Our design team has access to the latest software for development of any concept, right from initial conception right through to first steel. Our engineering office is led by highly experienced naval architects, with one of whom has developed key software for the moorings industry. Our renewable office, where I speak to you from today, is fully committed to all things renewable, but with specific focus on floating wind. Our renewable and operations team, who've literally been in the offshore industry for decades, there is little they don't know about ships, ports, facilities, hardware, and everything else related to installing equipment at sea. Next slide. Now, turning our attention to floating wind, FMS is currently wrapping up the ORE Catapult's PR6 moorings and anchoring project. The project particulars were developed with Catapult and the Floating Wind Centre of Excellence. In fact, many of the companies in the Centre of Excellence have been past clients of FMS, and it was great to engage with familiar faces outside the traditional oil and gas setting. Without giving too much away, we were tasked by the Catapult to investigate the optimal mooring system for a variety of given water depths and site exposures. The key aim of this study was to identify where and how the mooring system could be optimized to ensure further reduction in floating wind's levelized cost of energy. The study was conducted with a fully coupled wind turbine and floater model. The results yielded from the study helped to shed some light on the potentially unexpected challenges for both mooring design and supply chain issues for floating offshore wind in the years to come. The results from the study have allowed FMS to initiate further internal studies to tackle these forecasted problems well before they ever become major issues for the industry in 5 to 10 years' time. Next slide, please. So with that fast and high-level overview of FMS activities, I'd like to mention what we can offer you during your company's development in floating wind. Next slide, please. In addition to the points I mentioned earlier, FMS is highly involved in the industry's movement towards better integrated risk management strategies. In fact, last month, we submitted a proposal to the UK government to test our in-house and in-development conditioning-based monitoring software at full scale. We appreciate that as floating wind increases in magnitude, both in terms of turbine capacity and in sheer numbers of installed platforms, the remote monitoring of the mooring system will be a key factor in driving down costs of the energy system. We appreciate that floating wind will require new techniques and hardware to overcome the industry's unique challenges. And with this in mind, we are always researching the latest equipment to see how it can drive down cost and risk for our clients. We have worked with most suppliers in the industry and maintain our technology agnostic position. Simply put, we know what works where and what doesn't. This grants us the ability to develop solutions specific to your needs and requirements. Next slide, please. And that's the end of this rather quick overview of who First Marine Solutions are and what we do. Thank you very much for your time. And if you have any queries, please drop me a line on my email and I'll get back to you straight away. Back to you, Kevin.
Okay, thank you so much, Jason. And it's a really good example of how we have transferred so many skills and our knowledge from the oil and gas industry into floating offshore wind. We'll now move on to 2 presentations on dynamic cabling, starting with cable installation, and we'll hear from Rob Lindsay from Global Offshore.
Hi everyone, thanks for the introduction there, Kevin. Also thanks to SDI for this opportunity to discuss some of the aspects of cable installation that we within Global Offshore are involved in. Next slide, please. So for those who are unaware, Global Offshore is part of the wider Global Marine Group, which also includes Global Marine Systems, who provide fibre optic cable solutions to the telecoms industry. We've also got our sister company Seawind, who provide power cable and asset management services, as well as crew transfers and inspection, maintenance, repair services to the renewables industry. And we also have Ocean IQ, who provide an array of services to maximize cable lifespan, including route engineering, cable surveys, permitting, records management, and charting. So this slide here just provides a high-level overview of some of the services that Global Offshore provides to its renewable customers, right through from cable management, cable storage, to route planning, engineering, installation, and burial. Next slide, please. On the basis, the theme of this presentation is cable installation for floating wind opportunities. I thought it prudent that I discuss some of the works that we've recently completed on the Kincardine offshore wind project. So it's a bit of a common theme for the presentations today. So our scope for Kincardine was split into various campaigns, namely the installation of the export cable in 2018 for the demonstrator project, and the pre-trenching of the route for the second export cable in 2020. And we're currently involved in the future development for the second export cable installation, as well as installation of the 5 inter-array cables for the 9.5 megawatt turbines that I think have just recently been installed. So the next slide, please. So like any offshore project, detailed preparation is crucial to ensure that the project deliverables are achievable and that the cable can be safely installed in accordance with the requirements. So detailed route design and engineering is vital to ensure that the cable will be laid along the optimum route to safeguard integrity throughout the installation process, minimize any potential installation delays, and also provide the best opportunity for protection post-lay. There are a wealth of surveys that can be performed along the proposed routes, including surveys of the seabed material, so your geotechnical, your geophysical investigations, as well as surveys performed by either towed equipment or ROV surveys to identify any potential challenges or hazards along the route, such as significant boulders, debris, UXOs, or steep gradients. The list there at the bottom is just some considerations for floating installations. So with floating installations, it's typically deeper water depths, so it could be increased subsea currents. So it's important to ensure the correct assets are selected for the scope. You also have considerations for mooring chain orientation. So when you're doing your pull-ins, where you can position the vessel, etc., to ensure safe operations. So next slide, please. So when it comes to the actual cable installation, assuming that all the upfront engineering has been completed, as well as any route preparation works, first stage is, of course, loading the cable onto the vessel. That could be into a carousel or a reel type system. The images shown here are the Global Symphony loading the Kincardine cable from a manufacturer's facility in Norway. Cable consisted of 2 sections, a static section, which you can see on the right there in black and yellow, and the dynamic section at the bottom of the carousel in solid yellow. So once the cable and any ancillary items have been installed on board the vessel will depart to site and then set up at the appropriate location. For Kincardine, prior to the installation, we also performed a pre-lay grapnel run just to clear any missed debris that might include, say, old fishing gear or ropes, out of service products. Thereafter, we did a final pre-lay survey of the route just to ensure that the route was free of any hazards. And we also deployed a number of rock bags at the HDD, which is horizontal directional drilling. So the HDD duct just to support the cable catenary at the exit point there. Next slide, please. So although each requirement may have some differences in the scope, it's likely that a floating wind farm installation will consist of a shoreside pull-in for the export cable, offshore installation of both export and inter-array cables, as well as cable pull-ins to the floating structure. So for the Kincardine project, the first end of the export cable was pulled into the beach through a 500-meter HDD duct with the winch, which was set up adjacent to the transition bay where the cable was eventually terminated. We installed split pipe on the cable to protect the product at the exit of the duct on the seabed, so just protection from fatigue there. And you can see the split pipe there being overboarded on the bottom right image. Next slide, please. So upon completion of the first end pulling operations, the vessel then performed lay along the engineered route to the wind farm site. So lay speed is typically controlled using the deck tensioner on board in conjunction with the vessel speed and the touchdown point of the cable relative to the overboarding chute. It's continually monitored in real time using the ROV, and the typical lay speed that you could expect would be sort of 6 to 7 meters per minute. Per the middle image there, Euroduct was installed on the cable at the touchdown point of the dynamic section, just to provide a little protection there against fatigue. And the bottom right image there is the buoyancy modules, which were assembled on the product to form the pliant wave in the water column. The image on the left there is just a number of different catenary configurations that could be used for installation of dynamic cables, depending on the project requirements. And these are techniques that have been used and tried and tested in the oil and gas industry on flexible risers. So for Kincardine then, crane operations were utilized during the second end pull-in, ultimately to support the buoyancy modules and allow them to form the correct shape in the water column during the lay. The purple line there in the top right image is the plan view of the cable as it was pulled into the north leg of the structure. So the pulling was a little unusual in the sense that the I-tube was actually positioned on the opposite side of the leg. So we had to make considerations to the vessel position relative to the mooring lines. So quite a lot of detailed engineering there involved in that process. Next slide, please. So bend stiffener was installed on the end of the cable and pulled into the underside of the floating structure. So the bend stiffener essentially comes in two components. There's the pulling head and the main body. So the pulling head actually splits away from the main body once it's engaged in the I-tube bell mouth, which you can see here on the middle image there. Cable remains attached to the pulling head and is pulled through the I-tube to the top side of the floating structure on board. The image on the top right there shows a typical offshore wind farm second end pull-in quadrant. However, for Kincardine works, we actually had a bespoke bridle that was utilized to control the buoyancy arch and pulling head as it was cross-hauled into the floating structure. So per this image here on the bottom right. Next slide, please. So once the pulling operations were complete and the termination works and the final cable testing were then undertaken and completed on the top side of the platform, subsequently we performed post-lay trenching of the export cable using our Q1400 trenching system in a hybrid configuration. So that essentially means it's a combination of both chain cutting and jetting nozzles. However, we found that the soils were actually quite a lot more challenging than expected. So for the second export cable that was second export cable in 2020, we used our new PLP 240, which is a prelay plow that performs a simultaneous boulder clearance as well. You see it there in that middle image. So yeah, we used that to just to mitigate the potential risk associated with trenching in over-consolidated soils. And I think it kind of emphasizes that there's not always one definitive solution for cable burial or protection. I mean, there's the wealth of other tools out there and techniques such as controlled flow excavation, vertical injectors, cable plows, as well as fitting cable protection systems or rock placement and installation of concrete mattresses per the top right image there. Next slide, please. So after the installation and protection of the cable was complete and an as-left survey of the product was undertaken by the work class ROV, the image shown here is generated by our survey subcontractor on board the Symphony and shows the condition of the pliant wave there from the seabed through to the floating structure. You can see the buoyancy modules there forming the hog bend and then the cable sagging before its pulling location at the I-tube. So the pliant wave there into the north column of the floating structure. So although this was relevant to the demonstrator project, the principles are the same for the ongoing Kincardine development, which included the second export cable as well as the 5 inter-array cables. And next slide. Yeah, so that's a very, very brief overview of cable installation from our perspective and some of the works that we've been doing on Kincardine. And yeah, I'd welcome any questions. My email's there if anyone wants to get in touch and discuss anything further.
Rob, thank you so much for that very detailed run through using Kincardine as a case study. And now on to part 2 of our cable mini series. It's Ian Milne from Balmoral. Over to you, Ian.
Hi, good morning, good afternoon, good evening, everyone around the world. Really happy to be here, and just to kind of echo the words of some of the previous speakers, a sincere thank you to the SDI team. A really great job in promoting and giving us a platform to show our expertise, and also to show, lessons learned. A lot of the technologies and the companies that have been speaking already come from like the traditional energy background. So how we can kind of do that transitional piece. My name's Ian Milne. I'm the sales manager. I have a global responsibility for the renewables market at Balmoral. We're a privately owned company. Just a quick background on who we are for those people who don't know us. We are a privately owned company. Our same founder and chairman, Mr. James Milne, is the leader of our organisation. We are headquartered in Aberdeen. That middle image you can see there is our manufacturing facility. The actual manufacturing itself is about 250,000 square feet. Then we obviously have a lot more kind of storage land there as well. We have offices in Houston and in Newcastle. There's about 300 people within Balmoral Comtech. We also have the Europe's largest privately owned subsea test centre, where we have 23 pressure vessels for doing all various testing of materials and products, along with our own laboratory as well. So Balmoral Comtech forms part of Balmoral Group Holdings, which is still, the same founder and chairman, again, through Mr. James Milne. And within the group companies, we have commercial property. We also have a tanks business for doing large storage and industrial tanks. We have a company called Ace Winches, who do deck machinery and shore pool equipment for cable lay and cable installation. And then we have Blaze Manufacturing Solutions, who look at fire suppression and fire safety systems. Ralph Torr, who spoke earlier with the ORE Catapult, we have completed our Fit for Offshore Renewables program, which is something that Ralph was very heavily involved with prior to kind of heading up the Floating Offshore Wind Centre of Excellence. And as you've heard from Paul already, we are members of the Deep Wind Cluster, a very important one that we've been involved with, and also members of Aberdeen Renewable Energy Group and Renewable UK. Next slide, please. So who are Balmoral? What is it we're traditionally known for? I think an image speaks 1,000 words. Everything below that sea line, you'll see that on that image is what we're known for. We're market leaders in distributed buoyancy, dynamic bend stiffeners, bend restrictors, ROV buoyancy, surface and subsurface buoyancy, any sort of protection systems or uplift requirements subsea. Balmoral has got a raft of technologies and product solutions. We've been established for over 40 years, so we've got a lot of experience there in terms of tried and tested technologies, particularly in deep water, harsh environments is where we're certainly leaders in. Next slide, please. Renewables. So again, you look at this image here. What does that all mean? We've got a very important part to play with fixed and floating wind. If you look at that image on the right hand side there of the floating turbine, that whole subsea construction part, very, very similar to an FPSO. Instead, we're obviously working with dynamic cables here instead. But the kind of infrastructure, and Rob obviously touched on that earlier on before my presentation, that the infrastructure and the installation of these installations are very, very similar to that we've been in oil and gas. So you can see at the cable entry point into the foundation there, but you would have a dynamic bend stiffener, and then you have your buoyancy modules, and then also have the whole back tether systems as well, which can be a tethered line. And then you might have, various different kind of protection and bending, restricting technology there, depending on construction. And then if you look at the mooring, the guys at first were speaking there, the surface and subsurface mooring, that's products that we manufacture, and that kind of comes out with Balmoral. But that knowledge of dynamic natures is very, very well supported within fixed wind as well. I'll touch on that just quickly as we're here. If you look at these monopiles on the left-hand side, that point of the cable burial from the seabed into the cable entry position, that is very, very much a dynamic environment. And it's something that Balmoral has a lot of experience in, a lot of understanding. And that's in fixed wind, at least, very much a point of potential failure for the offshore wind turbine. So we've got that knowledge, and we're looking to have that protection solutions around all of our products. And then you can see the vessel there, and also on the shore you can see our friends at Ace Winches, and then also with Blaze, you know, you'd have your suppression systems and fire safety systems. Next slide, please. So the distributed buoyancy is very much a key item that would be needed for any sort of kind of commercialization of floating wind. And where Balmoral's very well positioned there is how I touched on, is our experience and our kind of knowledge and technologies and track record. At the moment, I think there's over 40,000 subsea modules of ours currently in operation around the globe. And we haven't had a failure, you know, and that's not through luck, that's through engineering, that's through the upfront validation of what's going to be happening, and particularly the environment. There is no one size fits all, but it's how you actually can manage the recipes to make sure that they can be fit for the projects that they're going to be in for. A couple of examples, you know, ranging from various water depths. If I think about deep water, in our traditional energy projects, if I look at, you know, Brazil or the Gulf of Mexico, you know, you could be anything up to 2,000, 3,000, 4,000 meter water depths. Whereas I look at deep water within floating wind, you know, it's maybe 500 or 600 meters, which still has its own challenges, but it does actually give you the opportunity to maybe utilize different foam systems, because the shallower depths that you have obviously affects the density requirements of the module. So you can use wax or syntactic foam or whatever it is you're going to try and do. And we have varying clamping solutions that can aid with installation, but more, and also very importantly, the longevity of a project, whether it's fixed or floating wind. Balmoral appreciates and understands that we're signing up to a 25, 30, 35 year lifespan, and part of our offering and part of our, you know, validation is that we do a lot of upfront engineering before anything gets manufactured. You know, the products are very standard, but when we're putting them into different environments, we need to make sure that they're going to be not going to be affected within the 1 in 100 year storms. You know, what's the seismic activity, what's the hydrodynamics activity, you know, what's the VIV impact, etc., etc. So that's all taken into account and taken care of at Balmoral. Take the next slide, please. So how do we select what the correct module is, or even certainly with our other products in terms of, you know, the dynamic bend stiffeners, etc. But we'll look at the geometry constraints, you know, the physical sizing of them, the spacing in between each module that's going to be on the line, you know, any, you know, minimum bending radiuses that we need to adhere to, that we're not going to obviously damage the cable, because that's why we're here is to protect it and give it uplift. Look at the depth rating, I touched on that. Very important part is that we look at the buoyancy requirements. We look at the EOL and SOL is end of life and start of life. So we need to look at the buoyancy requirement during the installation and everything's brand new. But we also need to calculate and understand what the end of life. So after that 30 years, how much buoyancy do we need to ensure that this system is going to be performing correctly? So that all gets taken into consideration. And one of the, you know, the key kind of the benefits of the Balmoral systems is that our end of life buoyancy is very, very good. You know, there's very little losses typically from the start to the end. So it means that we don't have to over engineer or make anything larger than what would need to be done. Installation, handling and lifting. You know, it's okay us going away and designing a buoyancy module, you know, certain sizes or whatever else. We need to make sure the guys in the vessels can physically hold them, can we actually install them, can we overboard them? You know, what is the vessel constraints? Is it a moon pool? Is it an overboarding chute? How are we actually doing this? So we have a lot of kind of collaboration. David Rennie, I mean, when he opened the session, he spoke about, he said the word cooperation, you know, and that's very, very important, you know, for any offshore installation, you know, from developer, operator, all the way through to the, you know, to the tier 3, tier 4 of supply chain. You need to understand how you're all, you know, piecing together to make sure this is actually going to work and safely and also on time for the greater good. And then within the clamping systems, you know, we'll look at the cable data, whether it's an umbilical cable or riser. You need to make sure that we're actually not going to breach any of the clamping pressures that are associated with the construction of the cable. You know, the maximum loads, safety factors, you know, dynamic application factors, temperature. You know, you make sure that these cables can run at the most highest possible rating they can to make sure that the systems and the turbines can run as efficiently as they can. So that all gets taken care of and taken into consideration when supplying a standard product into these environments. Next slide, please. How do we get costs down? And I think anyone within the supply chain will sing the same message of there's only so much you can do with cost. You know, every item has a cost, but how can we think smarter, not harder? You know, and for Balmoral, I mean, it's very much is at the core of everything we do is our kind of value engineering. That's the way you can reduce cost. And one of the biggest things for us is the early and meaningful dialogue, you know, and the availability of accurate information, particularly around the subsea environment, the cabling, you know, clamping loads, expansion values. All of these pieces of the puzzle are so important to ensure that you can actually value engineer the best solution for the job. Quite often we'll be asked for, Ian at Balmoral, I want you to give me 500 modules of X size and X uplift. Can you quote me, please? And then, which is fine, but we really get involved into the nitty gritty, if you like. And we ask to say, right, well, what's the uplift requirement? What's the vessel constraints? Can we make, for example, the modules larger? I can give you the same uplift, but I'll make the modules larger, which means A, there's less to manufacture, so that has a commercial benefit, and B, there's less to install. So right there, you know, I might be able to save days, weeks of a vessel installing at several hundred thousand per day. So that value engineering to kind of aid and get this cost down is really, really important. And the key message for us again is dialogue. You know, we're here to help. You know, there's a team of 300 at Balmoral that we're ready and waiting. You know, we've got various projects on the go, whether it's surf installations in oil and gas, but also within renewables for fixed and floating wind. You know, really like to get our thinking caps on and work together. Next slide, please. And very conveniently, a case study. I'm under quite a strict non-disclosure, so I can't disclose the project name, but we are currently working on an offshore floating wind farm at the moment. They did a pilot project for a handful of turbines where Balmoral, we weren't successful with the buoyancy or the bend stiffeners. But when they were coming to the kind of larger scale project, the dialogue started to increase, and we were invited to meet with the developer on several occasions. So he said, give us some feedback, tell us what you're trying to do, and as per always, you need to get the cost down. Buoyancy is too expensive. And said, well, let's put the value engineering hat on. Let's see what we can do here. And one of the points that was put across to us was the physical installation of each module and to get it overboarded into the vessel, into the water from the vessel. And they were saying that, you know, they'd experienced anything from 25 to 30 minutes per buoyancy module. Now, on a couple of turbines, you know, with a handful of modules, that's not that big deal. But when you're looking at the larger scale and the larger, particularly moving forward, the larger installations of these projects, you know, how can we get that time down? So instantly we said, well, we have a particular clamping solution, which we call the Balmoral Integral Clamp. It's a patented solution. And what that actually does, it reduces that installation time. And by the way, it's installed and clamped together. And we managed to reduce that from, well, what they had experienced at 25 minutes down to 6. So as we're looking at a large installation, straight away, I've managed to save hours and hours and hours, days and weeks of a vessel. And then we worked with the cable manufacturer and the installation contractor to ensure that we could actually optimize that quantity. And again, that was through the value engineering piece. We looked at the size, we looked at the uplift, and then we actually engineered the modules to be larger. Like I said, we would install larger than, which had that commercial improvement. And then we had the less of them to install. So again, we've saved more time again, which is saving additional cost. We also looked at the water depths. We were given a water depth of X value. And we said, is that where the modules are going to be sitting the whole time? Is that during installation? Is it what we call a wet park, where it's just going to be there for a while, subsea? Or what's the final kind of positioning within the installation? And then that information came across to us and it was all confirmed, which then was like, oh, great. Well, we can actually be, it's a lesser density we need. So we use a different material again. So all that kind of cost saving, all that from initial this was our problem. You're too expensive. You know, buoyancy is too expensive as a whole. You know, and we said, right, well, let's see how we can get that down to you. So that early engagement piece, what I touched on, that early dialogue, can really help. And then subsequently, we're also involved very heavily with that project with the whole back tether systems as well. So there's efficiencies through there in terms of production, in terms of project management, etc. Next slide, please. This is for fixed wind, but bearing in mind that I touched on earlier, that dynamic knowledge, that dynamic environments. I'm just going to spend a couple of seconds on this slide, which is our cable protection system, which is known as the Balmoral Fiber Flex. A very unique system, no other system like it on the market, where we've actually got quite revolutionary composite nature of a woven fiber with a very thin layer of polyurethane. So what that does is in the dynamic section of a fixed offshore wind turbine is provide a very good stiffness and stiffness properties to then protect that cable from burial into entry. And as I said, that is very much a dynamic environment. So utilizing our knowledge of dynamic environments, floating, and what's typically used when you're exposed to the elements, coming with this technology here, very market leading, very good thermal properties, and very good instability. We're actually offshore just now on a project, and I'm getting some live feeds and live images back to us, and having some very good performances of that installability, as I said there just now. So next slide, please. I touched on it. The engineering piece is so important. It's, as I said, it's so key. I mean, we can supply you products at X quantity and X value, but if you want to look at what can be done more, how can we get closer, and that kind of cooperation that David said, and I think such an important word. So we work with all the teams, and I won't list every single discipline that we have there, but as you can understand, it's all very much integral to everything that we're doing. And then the next slide, please. And thank you very much for your attention. My contact details are there. What I would say is it's very hard to take everything in 10 minutes. Our website is bang up to date. We have an interactive presentation where you can actually go zoom around, click on monopiles, click on turbines, click on buoyancy, click on anything you want, and it'll give you all the information. It'll give you all the products there. But we certainly have an open door and collaboration. Happy to speak with anyone. So on that note, I'll pass you back to Kevin, and thanks again, everyone, for your time.
Ian, thank you so much for that. And that concludes the supply chain innovation section of the programme. We'll now move on to the final part of the programme and hear from Stephen Alexander from the Scottish Fishermen's Federation on fisheries and offshore wind. And we've actually received a few questions in the Q&A box about it already. So over to you, Stephen.
Thank you, Kevin. Good day to everyone. I appreciate the opportunity to present today. In the time available, this presentation will focus mainly on the role of SFF Services Limited, which is the commercial wing of the SFF, and the part that it has played in the relationship process with other users of the sea, such as the oil and gas industry, and in more recent times, offshore renewables. Next slide, please. The SFF comprises 8 constituent member associations, some based on geographical location, some on method of fishing. Next slide, please. Established in 1973, the Federation is the primary political and trade protection umbrella for the Scottish fishing fleet. It currently comprises around 400 vessel members. Its constituent associations account for over 90% of the total Scottish quota and over 60% of the UK total. And since its formation, the SFF has been instrumental in establishing the main consultative forums for meeting with the energy sector. Next slide, please. In relation to the offshore energy sector, much of our experiences to date have been in connection with the oil and gas industry. In the early days, we had 2 industries, a shared sea space, shared basics, but with very different characteristics, one contracting, one super expanding. Very early on, there was a recognized need for a process of governance. This led to the formation of the Fisheries and Offshore Oil Consultative Group, and engagement with relevant government agencies. Coexistence through communication and compromise, conflict at first but benefit later. Planning and licensing consultation was developed, with the fishing industry becoming a statutory consultee. I can confirm that similar type consultative groups have been developed for the offshore wind. Next slide, please. That's it coming, thanks. Let's be honest, in an ideal world, all the different sectors of the sea would prefer to have the sea to themselves. But as we know, in the real world, it doesn't quite work like that. The following animation will hopefully highlight the need for coexistence in a shared sea space. So we've got various, the first screen was how the fishermen would have seen that area pre-oil and gas and offshore renewables. So we've superimposed the oil and gas information. We've now put on the renewables information. If we now add on ScotWind leasing proposed future sites. And then finally, if we superimpose fishing data belonging to 3 fishing families, I think we'll get the point across that we have a busy, very busy area. Next slide, please. Rather than being standoff and chasing loss of access payments, in 1986, the SFF formed SFF Services Limited, set up to provide diversified work opportunities for member vessels, ideally and wherever possible looking to engage the fishing vessels who face having their normal fishing patterns disrupted or end up being temporarily displaced by offshore installation or decommissioning activities. We believe that this approach has played a major contribution to minimizing conflict by helping to establish and nurture an excellent long-term working relationship between the Scots fishing industry and the offshore energy sector, minimizing conflict by working with and not against energy industries. Next slide, please. It's certainly not a normal business model that we have developed, but we have done our best to stick to the ethos of using local boats wherever possible. Since the start of the millennium, over 550 different fishing vessels have undertaken offshore-related work through SFF services, accounting for over 105,000 vessel days at sea. A special mention must go to the oil and gas industry on this front for recognising the uniqueness of the SFF vessel provision model. As highlighted earlier, similar relationships are being developed with other offshore industries such as renewables and subsea cables. Next slide, please. Working for our existing client base means having high safety and operational standards. This is something that the company has worked hard to develop over the years and includes the provision of detailed vessel and offshore personnel operational procedures, manuals, and obtaining various QHSE accreditations. A dedicated in-house team able to deliver 24-hour marine support is in place and includes a dedicated QHSE manager, safety officer, and marine assurance officer. Next slide, please. The vessel services we provide include guard stroke fishery liaison, survey support, site remediation and seabed clearance, environmental monitoring, oil spill response, plus inshore survey capabilities. Next slide, please. The personnel services include fishery liaison officers, marine mammal observers, passive acoustic monitoring, acoustic deterrent device operators, as well as offshore and onshore consultancy. Next slide, please. We have always been open to diversify, and new areas of operation include debris clearance for decommissioning, AUV deployment, and drone deployment. Next slide, please. Consultancy services are provided, and these include delivering fishing awareness sessions to the offshore industry and distribution of electronic awareness data to fishermen in collaboration with the FishSafe decommissioning project, which I will touch on shortly. Next slide, please. The next few slides focus on safety and how things have moved on a great deal in the last 25 years or so. Next slide, please. The Fishery Legacy Trust Company was launched in 2007 by the OGUK, the SFF and the NFFO to help keep fishermen safe in UK waters by providing up-to-date information on all seabed hazards relating to oil and gas. Similar complementary information is also now being made available in respect of offshore renewables and subsea cables. Next slide, please. Information is provided through a number of mediums. We have the Fish Safe unit, where we have 6 monthly data updates provided. In the interim period, we have the fortnightly online bulletin updates. And the equivalent Fish Safe information system data rollout is provided on an annual basis in respect of offshore renewables and subsea cables. Next slide, please. Predominantly via the guard vessel visits, a positive safety byproduct of this engagement has been the opportunity presented to educate fishermen regarding the scale and level of subsea infrastructure within the UKCS, so that they are better informed when they return to their normal fishing operations after completing a period of guard duty. The current slide provides an overview of how a new piece of kit, in the bottom right-hand corner there, fits into an existing field. And the next slide shows how that manifold looks like in real life. Next slide, please. I'm pleased to report that by and large, the fishing industry's current relationship, which has been developed over a number of years with the oil industry, is one of mutual respect, mutual understanding, and willingness to engage. And this is what we are working to develop and hopefully replicate with offshore renewables sector. Next slide, please. Maintaining the relationship during the decommissioning phase. This is a phase that we are entering with the oil and gas industry, but certainly something to bear in mind in respect of offshore renewables. How strong is the relationship? It is easy to have a good relationship during the periods of good times with high oil prices, but how does the relationship hold up during the decommissioning phase when it is more or less all money going outwards for the oil operator or wind farm developer? Ideally, at the point of project conception, there should be a clear picture of the full life cycle of the development, with plans in place to return the seabed back to its pre-development condition at the end of field life, to allow fishermen to safely return to fishing the locality. Next slide, please. Unfortunately, however, as we are finding out with oil and gas, this is not always possible. Next slide, please. To conclude, the fishing industry's expectations in working with the offshore energy sector are a safer working environment in perpetuity, limit loss of access, respect for previous commitments, acknowledge the problems, and a genuine attempt to find solutions. And that's me, Kevin. Thanks.
Stephen, thank you so much for that overview of how the fishing industry and the offshore energy industry can not only coexist, but also prosper with each other and support each other. So thank you very much, Stephen, for that overview. And that brings us almost to the end of today's online event. I appreciate that 2 hours is quite a long time for you to sit through online presentations, but hopefully you've gained a bit out of this conference by way of technical understanding, but also what Scotland has to offer. And just to reiterate, the full recording will be made available to you all after this event in the next few days, and you would also receive replies to any questions that you typed into the Q&A box but were unanswered during the conference itself. And with that, can I hand you back to David Rennie for some closing remarks? David, are you there with us?
Can you hear me, Kevin?
We can, David.
I'm having some real challenges today. Apologies for everyone. So I'll probably just stick to the voice only, I'm afraid. Just to say a couple of closing remarks, just to wrap up today. And thanks for everybody for joining. We've covered a lot in our 2 hours. As Kevin has said, and I think we said at the start, obviously we're recording today, and a link will be sent to everybody around that for the next few days. So in terms of follow-up, if any of today, anything of interest, you have some questions, a query, as I said at the start and elsewhere, we've got a number of trade officers or trade colleagues based around the world to discuss, how you might want to work with Scotland on floating offshore wind. I think Kevin is hopefully sharing a slide with you at the moment with the names and contact details. We're also planning a number of sort of trade missions, the maybe hybrid trade missions. We'll wait and see, but focused on the US, Western European and East Asia markets over the next 9 months, which will, enable companies to learn about markets and markets to learn about companies. So I just wanted to wrap up to say thanks to everybody for speaking today. In fact, for the speakers that are still with us, and I know I'm breaking my own rule, but because of my technical nightmare I'm having, if you could put on your camera just for a second, just to say to all the speakers today, thanks to everybody for your time and taking us through so much, really impressive in terms of the know-how, the technical expertise expressed on this call. So right through a whole range of speakers today in terms of markets, individual company capabilities, etc., etc. So if all the speakers could just put the camera for a second, and we can thank them and wave them goodbye. And also just to say, I think we've had over 20 countries calling in today. We certainly had over 1,000 people registered to attend, so that shows you the interest in this market. And my final thanks is really just to Kevin, my colleague Kevin, and the team just for making today happen. These things, as you all know, don't happen by themselves. So a whole amount of planning, Kevin, particularly Kevin and his team, and others as well. But so I just want to say thank you all very much. We'll leave the event there. Enjoy the rest of your day. And my final point: if there is anything, no matter how insignificant you may think it is in terms of a query or a question, please follow up with our team, and we'll do our best to help you. Thank you so much, and have a good day, everybody. Thank you.
Thank you.
Thanks, everybody.